So your notes today are going to be trig integrals, and we are specifically looking at the other type where we do secant and tangent, and the idea is the same. So it's going to feel kind of similar to the other ones. Integrals, secant and tangent. All right, so your rules or your hints for this one. First, we're always going to try to use substitution because sometimes they're going to be straightforward problems that are easy to do, and then we like that. Okay, so we always try that first. Second, when secant x has an even degree, save a secant squared. Why, if you think about how this worked before when we did sine and cosine, why would you save a secant squared to be the du?
So you can have some as your u.
So your u would be tangent,
Yeah.
because what's the derivative of tangent? Secant squared, right? Okay, so when we think about that, if we have an even exponent on that, then we're going to save the secant squared to end up being our du, because we know that our u is going to end up being tangent. All right, so save secant squared for du and convert the rest using the Pythagorean identity. So when I say convert the rest, I mean convert the rest to tangent. Yes, sir.
This is the second time I have it. I really forgot my question. Oh yeah, what if it's just secant squared?
That would be one. The integral of secant squared is just tan.
Yeah, but I'm saying like
That's on the yellow sheet. If it's literally just secant squared.
no, but you're saying okay when secant is even. I'm assuming that I also have tan in there somewhere.
Yeah.
I'm saying what if the even?
So let's say you had secant to the fourth times tan. Then you would take one secant squared and you would use the Pythagorean identity to convert it all into tangent. And then the other secant squared would stay as a secant squared.
Now
And then
what
the
if I
whole
Secant squared.
if you
has tan.
secant squared has its own integral, that's an easy problem. That's like back weeks ago.
I'm saying secant squared times tan. So I get that.
Then you would say your u is tangent and your du is secant squared.
Oh yeah. Okay.
That would be like step number one. That's a regular u substitution problem. Okay. All right. Third, when tan is odd, not tax. When tan x is odd, we are going to save a secant x tan x. Why are we saving a secant x tan x?
So because that's one of the derivatives.
Because that is the derivative of secant.
That makes sense.
Okay? So that means we're going to save this for du. And then we're going to convert the whole rest of the problem into secants. Alright? And then our u would be secant, and this would be the derivative of u. So for du, and convert the rest using the Pythagorean identity. All right. So we're going to go ahead and do some examples. And the instructions will always just say integrate because they're not going to give you any clues. So if we were to integrate tan to the sixth times secant to the fourth, what did we say we should do if secant was even? Save a secant squared, right? So I'm going to rewrite this as tan to the sixth times a secant squared. And then I'm leaving a secant squared there to be my du. So if this is my du, what do I want the u to be? Now cover this up. If I want the u to be tan, because if I say u is tan, then the derivative of tan is secant squared. Okay? So that means that I need to take this and convert this so that it's all just in terms of tan. Right? So I've got the tan to the 6th to start with. And then I use my Pythagorean identity. And secant squared is the same thing as 1 plus tan squared. That's me using my Pythagorean identity. And then I leave this sitting on the end to be my du. So u is tan x. And du is secant squared dx. And so now I can replace the tan with the u. And it gives me u to the 6th times 1 plus u squared du. You see how similar that is to the ones that we just did?
So much.
Yeah. Okay, now, and that's a 6. I don't know if you could tell. All right, what do I do now? I got to distribute that. I can't integrate it the way it looks right now. So I'm going to say that that is u to the 6th plus u to the 8th du. Now what do I do? Wait,
no, you gotta integrate it.
I gotta actually integrate it. So I was working it out. I was making it so it was ready to integrate. Now I have to actually do the integration. So I've got plus 1. So that gives me 1/7 u to the 7 plus 1/9 u to the 9 plus c. And then what is my final answer? Yeah, plug tan in. So 1/7 tan to the 7th of x plus 1/9 tan to the 9th of x plus c. Alright. Let's work on the next one. Woo! These are so fun. I love these. Tan to the 5th theta times secant to the 7th theta d theta. So here, remember our two rules were if secant is even, we do something. That is not the case here. The other rule was if tan is odd. So if tan is odd, what do we save? A secant tan. Okay. So I'm going to rewrite this. I'm going to have tan to the 4th times secant to the 6th. And then I was saving a secant tan. So the secant tan is what I'm saving to be du. And secant tan is the derivative of what trig function? Secant. So that means that all of these have to be secants. That's what we want. All of these to be secants. Okay. So how am I going to fix it so that all of those become secants? So this is going to be secant squared minus 1, but that's tan to the 4th, not tan squared. So we're going to have to square it. Right? Okay. So I'm going to write secant squared minus 1, that's tan squared. I need it to be to the 4th, so I have to have tan squared squared.
Why are we subtracting 1?
So if you look at the Pythagorean identity says 1 plus tan squared equals secant squared. And I'm replacing it in for a tan squared, so I had to minus the 1 over. So secant squared minus 1. And then we also have our secant to the 6th. Okay, and then we have the part that we were saving to be the du. Now, when you do this, we're going to have a bit of simplifying before we can actually integrate this. I think it's a little bit easier to do the simplifying after you've put the u into the problem. A little bit, it seems to be. So I'm going to go ahead and I say that since this is my du, I already know that my u has to be just a plane secant. Okay, so u is a plane secant. Du is the derivative of secant, which is the secant theta tan theta. And I can go ahead and put my u's in the problem and simplify that as u's, making my life a little bit easier. So that would be u squared minus 1 squared times u to the 6th, right? Hey, coach. Math coach? No. Rude.
I just call everybody coach.
All right. How do I fix this?
You gotta distribute the.
Wait.
No, you distribute the.
You gotta foil that out.
You gotta foil and then distribute. You guys concerned me. We gotta foil, then distribute. So u squared minus 1, u squared minus 1. When we are done with the foiling, then we can do the u to the 6th. So that would be u to the 4th. And then what? Minus 2u squared plus 1. Okay, so that's what we had when we foiled. Is that what you guys got when you foiled?
That's what I wrote down.
Okay, and then we got to distribute.
You trying to roast me, boy? You trying to roast? Now you're angry again. What you got to put?
Isn't that supposed to be divided by 11?
Yep. It was a typo, don't worry about it. Get it? Get it?
This is so.
Alright. And then plug the secant back in. Alright, so 1/11th secant to the 11th x minus 2/9 secant. Thank you. Secant to the 9th theta plus 1/7 secant to the 7th theta plus c.